Charlie here, continuing with our graphing topic from the topic in chapter 1 in graphing in only one quadrant with all positive values. We are now going to extend that coordinate system to positive and negative values, and that gives us a coordinate plane that's split up into 4 quadrants. Quadrant 1, the one that you work on first, with all positive coordinates, and then quadrant 2, negative x and positive y's, quadrant 3, where everything is negative down here, and then quadrant 4, where the x is positive and the y is negative. And the origin is in the middle, the x-axis, positive numbers to the right, negative to the left, and on the y-axis, positive numbers up and negative numbers down. Talks about how video game programmers use a coordinate system, and that's the thing. Moving things around on the coordinate system is how all graphics are done on everything electronic. So it's a very important thing to be able to operate on the coordinate plane, and we'll do lots of that work this year, and you'll do it in future years as well. Okay, so every point on here has an x coordinate and a y coordinate. So write the ordered pair that names each point. So point J, what is point J? Well, it's at -4 on the x and -3 on the y. So the answer is -4, -3 for point J. And -4, -3. And for point L, okay, so left and right, it's at 2 on the x-axis, and then down 2 here on the y-axis, so 2, -2. 2, -2, right? What are the coordinates of point M? 0, 5. These are ones that frequently get mixed up when there's a point on the y-axis or the x-axis. So just remember, you're going left and right first, and if it's on the y-axis, you didn't go left or right at all. The x-coordinate is 0, and the y-coordinate is 5. Point K. -5 and 2. -5 and 2. You can go the other way around, of course. If you are given coordinates, then you should be able to plot the points. Here's where they talk about the quadrants, right? So the two axes split the coordinate plane into 4 quarters. Quadrant 1, where everything's positive. Then we go counterclockwise to quadrant 2. Quadrant 3, down here where everything is negative, negative and negative. And quadrant 4, positive and negative. Okay, so in here, it's going to ask you to plot the point and then name which coordinate it's in. Okay, you should be able to look at the coordinates here. I'm sorry, which quadrant it's in. You should be able to look at the coordinates and know right away which quadrant it is in. Okay, or you can graph it and then kind of see from there. So -2, -4 is point A. So from the origin, we go 2 to the left for the -2 on the x, and then down 4, we graph the point and make sure to label it with a letter. Okay. And then the other example, point B at 0, 2. So we don't go left or right at all. That's the x-coordinate of 0 and up to point B. You do not have to write the coordinates when you are graphing these points on a graph. You don't have to write these numbers. Right? You do have to label it with the letter so that you know that's where that point, that point is labeled with that letter. But you don't have to write the coordinates. Okay, so here's some got it's. Kind of hard to ask these questions digitally. Point H at 4, -3. Okay, at 4, -3. So we start at the origin. We go 4 in the x and -3 in the y. And we mark that as point H. And what quadrant is it in? Well, it is in quadrant 4. The x is positive and the y is negative. Quadrant 4 in Roman numerals typically. So quadrant 4. All right, next one. Point I guess that is, point I, at -1, 4. So we start at the origin. We go -1 in the x and +4 in the y, and label this point I. And then to answer the question of which quadrant is it in, the x is negative, the y is positive. It is in quadrant 2. Point J. Point J is at 0, -2. So we start at 0, the origin. We do not move left or right at all. And we go down 2. And we label point J. Now the question is, which quadrant is it in? Well, it's on this line. It's on the y-axis. It's on no quadrant, okay? It's in the border. So we say none, none, for which quadrant is it in? And really the better answer is that it is on the y-axis. All right, so let's move to real-world graphs. Again, we spent a lot of time in real-world graphs when we were talking just about quadrant 1. Some real-world graphs have positive and negative numbers on them. Now, they took real-world situations here, but these are really not real-world problems. These are more algebraic problems, okay? But because there's not really an application where you would have this, the difference between two people's golf scores is 2. And if X is John's score and Y is Terry's, then make a table of possible values of X and Y and graph them and describe the graph. So in this situation, you can pick any value you want for X, right? And then you can figure out what the Y value is to make the equation true, right? To make the difference between their scores 2. So if X is 2, well, then Y is 0. Okay, if X is 1, 1 minus what number is going to equal 2? So then it has to be -1 to get the difference of 2 between the two scores. If X is 0, then Y is -2. Because it's the difference between John and Terry. So John minus Terry has to come up to be to equal 2. So 0 minus -2. If John's is -1, Terry's -3. Okay, so that's how they built this table. The reason I put a Mr. Yuck here is because real world graphs ought to have labels on them. Okay, the real reason this is a Mr. Yuck is this is not really a real world graph. Okay, it's more of an algebraic exercise, but which is okay. All right, so make the table possible. Graph the ordered pairs. So they graphed all these points: 2, 0, 1, -1, 0, -2, -1, -3, -2, -4. Right, so they're all graphed. Then it says describe the graph. So the points make a straight line. I mean, they even said, oh, the points are along a diagonal line that crosses the y-axis at -2. There's lots of stuff you're going to learn about lines like this over the next few years. So this beginning part, right now, probably best to just observe that they make a straight line. Okay. And again, like we talked about in the previous video on graphing, if there are no numbers listed on your coordinate plane, then you assume that each line, each unit is worth 1. In this case, 1 shot in the golf score. Okay, so there's a got it here. Before we get to that, let me just remind you of these things that real world graphs need to have, right? A title, labels on the axes, proper scale, okay, all those things. And again, this graph of golf scores is a little bit kind of weird, but we'll go with it anyway. The sum of two golf scores is 3. If X is one score and Y is the other one, make a table of values for X and Y, graph the ordered pairs, and describe the graph. Well, I think I forgot to describe the graph in my work here. We'll get to it. Okay, so first we will make a table of possible values. So we'll start with a table of values. There's X and Y. The sum of the scores is 3, so you can pick whatever you want to start. I started with -2 for X. And so if the sum is 3, then and Y has to be 5. If X is -1, then Y has got to be 4. If X is 0, the Y is 3. If X is 1, the Y is 2. If X is 2, the Y is 1. We couldn't pick other values here. This table could go on forever in both directions. Okay. All right. Once we have the table, let's make a graph. So I've given you this coordinate plane already with numbers on this one. A title. What is the title of this graph? golf scores add to 3. That's what I called it. It's kind of, again, not really a very good real world example, but it is an example. All right, label. So what's going to go here on the x-axis? Well, x is the first score, we'll call it, making y the second score. Okay. And now we're going to graph the points. So we start at -2 and 5. -1 and 4. 0, 3. 1, 2. 2, 1. And of course, you can probably see that you could just extend this pattern forever in both directions, an important thing that we will learn later on. Okay. So there's a graph of the ordered pairs. Describe the graph. Straight line. That's enough for me. Okay. So really, we're just getting used to graphing on the coordinate plane. We'll be doing a lot more with this in the weeks and months to come.